Miscellaneous exercise 11. Question number 1. Show that the line joining the origin, so let origin be 0, 0, 0, null vector, and the point 2, 1, 1, I'll take that as A, 2, 1, 1. So the direction of the line OA will be this direction of the line through this direction of the line, which is given by this minus this, which is 2, 1, 1. 2 minus 0, 1 minus 0, 1 minus 0, and line through which 2 points? Let me call that as B of 3, 5, minus 1 and C of 4, 3, minus 1 has direction. Let me write the vector BC, which is given by C minus B, 4 minus 3, 1. This is minus 2 and this is 0. So this is the direction of the line through these 2 points. This is the direction of the line through these 2 points. You want to show that they are perpendicular. So we just get the dot product. So therefore, vector OA dot vector BC equals to here 2, 1, 1 dot 1 minus 2, 0. So this is 2, here minus 2 plus 0. So we have 0. So dot product of the directions, it's like this, remember. This is origin, for example. This is A. So this is the direction of the line OA. The other line may be like this. This is B here and this is C. So this is the line BC. Direction BC, direction OA. You want to show that they are perpendicular. So just you shown that the dot product is 0 here. And therefore proved. Therefore the lines are perpendicular. Question number 2 here. The second question. You are given direction cosines of two mutually perpendicular lines. Show that the direction cosines of the lines perpendicular to both are this. Okay. Direction cosines of the given two lines are these and this. Now given two lines are perpendicular, you are given. So therefore their dot product must be 0. So L1 dot L2 plus M1 dot M2, dot means into here, plus N1 into N2 equals to 0. This is given to us, remember, right? As lines are perpendicular, if you want you can write. Lines are perpendicular, therefore dot product of direction cosines must be 0. So this into this plus this into this plus this into this. So we'll use this. You can call this as 1 here. Now what you want? You want the direction cosines of the line perpendicular to both these lines. Now when you have the word perpendicular to both, then what we do? We get the cross product. Fine. We get the cross product. So we just find the cross product of the given two direction cosines. So I'll write here direction cosines of the line perpendicular to both the given lines equals to, here I'll just take the cross product. So let me call this as just vector L and this is vector M. So here what you'll get? You'll get the L cross M upon their magnitude. You know the definition, beginning of the previous chapter, unit vector. direction cosines always unit vector. So we have the cross product upon its magnitude. Fine. So this represent a unit vector which is perpendicular to direction cosines of the both the given lines here. So we are just going to find this cross product and its magnitude, and with the help of this equation 1 you are going to show that required direction cosines here. So first I'll get the cross product. So here you have L1 M1 N1 cross L2 M2 N2. You know cross product is the determinant with I, J, K. Here L1 M1 N1 L2 M2 N2. Now here M1 N2 minus M2 N1, this into this minus this into this, minus into I cap, here minus L1 N2 minus L2 N1 into J cap plus L1 M2 minus L2 M1 into K cap and its magnitude, remember, and its magnitude, that is you can just use the definition, and here length of the cross product of these two, which is root of M1 N2 minus M2 N1 the whole square plus L1 N2 minus L2 N1 the whole square plus L1 M2 minus L2 M1 the whole square inside the square root. You know this. You need to simplify this. You just simplify this, open all these brackets and use equation 1. You'll get the 1. Using 1, use 1 you need to use, remember, and this one also I suppose you need to use. Here these are the direction cosines, therefore this L1 square plus M1 square plus N1 square is 1, L2 square plus M2 square plus N2 square, this is also 1, right? With the help of this and this, you can just show that this expression has value 1. So this will be just 1. And here this cross product I'm going to place there. So if I place the cross product, let me put the cross product there. So I'm just putting the value of the cross product M1 N2 minus M2 N1, comma, I'm taking this minus sign inside, this minus inside, so you have L2 N1 minus L1 N2, comma, L1 M2 minus L2 M1 upon that length is just 1, and therefore you have this expression. This and this, these are the required direction cosines. Right? What I did, I repeat. You know this is very basic formula to get the unit vector perpendicular to both the lines. So what you need to do, cross product upon its magnitude. I've just computed cross product, this simple cross product. This is its magnitude. If you use the equation 1, you just simplify, open, you will get this is equals to 1. Now I'll place the value of this magnitude and this one over here. So this is a numerator expression upon 1. So we have this. Third question, question number 3. Find the angle between lines whose direction ratios are this. Right? For given two lines, for given two lines, direction ratios we are given. Let me take one direction ratio, as vector A here, which is ABC, and the other one is, okay, I'll call this as B1 as we were using, and B2. Anything, symbol is not important. B minus C, C minus A, and A minus B. These are the direction ratios directions of the given two lines. You want the angle between these two. So let theta be the measure of angle between these two. Angle between two lines. Angle between two lines. So therefore, which formula? Cos theta equals to B1 dot B2 with modulus upon individual modulus. Individual modulus. So vector B1 with its magnitude, vector B2. Right? This is basic formula we have used number of times earlier. So let's get the dot product. A into B minus C plus B into C minus A plus C into A minus B. This into this plus this into this plus this into this upon their magnitude. That's the magnitude of vector B1 into magnitude of vector B2. Now you just open the bracket. Here you have AB, here you have somewhere minus AB, minus AC, you see plus AC. So numerator expression is 0, you can just verify. So cos theta equals to 0. So therefore theta must be 90 degree or pi by 2. So it means two lines are perpendicular. Right? You just open the bracket, you will realize that the numerator expression will be 0. So 0 upon its magnitude. So cos theta will be 0 and therefore theta is 90 degree here. In fourth question, you want the line through origin. So you need a fixed point here, which is origin, which we usually write as vector A, which is 0, 0, 0. Line passes through origin. And parallel to which axis here? X-axis. So therefore the direction of the line is same as the direction of x-axis. Therefore direction of the line, that is equals to x-axis. What's the direction of the x-axis? That is I cap, which is 1, 0, 0. It's like this here. There's x-axis, y-axis and z-axis. Line passes through origin here. And parallel to this x-axis, remember. So the direction of the line is same as the direction of the x-axis, which is, here I cap, which is 1, 0, 0. So therefore line is given by, line is here. I'll write the Cartesian equation. X minus x1 upon L1, A equals to y minus y1 upon B equals to z minus z1 upon C. Directions of the line. X minus x1. x1 means 0 here upon 1. Y minus y1, which is 0 upon here 0. And z minus 0 upon here also 0. So we'll get this x upon 1, y by 0 and z by 0. This is the required line in Cartesian form. Now I already mentioned earlier, you are having upon 0, it doesn't mean that it is undefined. This is a standard way of writing the equation of the line in space. Remember, that's in R3. So this is the required line. The only important thing is what's the direction of the line. That's the same as the direction of the x-axis. Why? Because your line is parallel to x-axis. That's given to you. Fixed point also you are given. Whenever you want to get the line, you need a fixed point and its direction. So here is the direction, here is the fixed point. Question number 5, fifth question. The coordinates of these 4 points you are given. The question is find the angle between these two lines AB and CD. Okay, so you are given this here. You are given A, you are given B here. I'll not do this. You are given C here and D. Now we want the angle between which two? AB and CD. So one line that passes through these 2 points A and B. You have the other line that passes through C and D. We want the angle between these two. Let's call that as theta. Do you remember what you need to find here? The direction cosines or direction ratios or just direction. So we need to get the vector AB, vector CD. So direction ratios, it is same as directions, remember. Direction ratios or directions of given two lines will be here vector AB, that is this. You know how to do this. This minus this. Vector CD, this also you know how to do. This minus this. Get this. And then use which formula? You know, cos theta equals to vector AB dot vector CD with numerator modulus upon their magnitude. Vector AB into vector CD. This is what you are going to use here. Fine. Cos theta equals to this dot this upon their magnitude. So you can simplify this much. The sixth question, you are given that two lines are perpendicular. You want to get the value of unknown k. So what we need to do? We just write the direction ratios, directions of the given two lines. So I'll write here direction ratios of given two lines. Let's write vector b1. You can see the first one, it is already in the standard form, -3, 2k and 2. Which standard form you need to recall? X minus x1 upon a, y minus y1 upon b equals to z minus z1 upon c. This is the standard form of a line in a Cartesian form. So given line, it is already in this form. So we have this. Then what about the other line there? For the second line, let me call that as vector b2, which is 3k, 1 and -5. Now lines are perpendicular. Therefore their dot product equals to 0. So you have here this into this, which is -9k plus 2k minus 10 equals to 0. So you have -7k minus 10 equals to 0. So therefore k will be here minus 10 by 7. This is the value of k here. The sixth question. Question number 7. The seventh question, what is asked? Find the vector equation of the line through this and perpendicular to this plane here. So we want a line that passes through which point? 1, 2, 3. Remember, here you need a fixed point and the direction of the line. So point is this, that is vector A as per our notation, which is nothing but here 1, 2, 3. Line passes through this and perpendicular to the plane and perpendicular to the given plane. Now here it's like this. This is a given plane. The required line is like this. This is the required line. It's perpendicular to the plane, you can see, like this. And this is the direction of the normal. Here, this is the direction of the normal, vector n. What is the meaning of this? It means direction of the normal is same as the direction of the line here. So I'll write therefore direction of the line, required line obviously, equals to direction of the normal. They are parallel, you can see. Direction of vector n. Now can you see what's the direction of the normal? It is in which form? R dot n equals to 0. So what is the normal there? I cap plus 2j cap minus 5k cap. This is the direction of the line. This is nothing but the fixed point. Just I repeat the solution. See, what I'm trying to tell you is the required line is perpendicular to the plane. Normal is always perpendicular to the plane. It means the direction of the line L is same as the direction of the normal. So direction of the line is just given by what? Direction of the normal. So this is the direction of the line. This is a fixed point. So we can write here vector form. In this question you are asked specially vector form. Remember, if nothing is given, we can get just Cartesian form. So I'll write here vector form of the line is, if you remember, vector r is equal to vector a plus scalar into direction of the line, where scalar is number here. So therefore we have here vector r, that's arbitrary vector. Which fixed point you are given here? I cap plus 2j cap plus 3k cap plus scalar lambda. What's the direction of the line? I cap plus 2j cap minus 5k cap. This is the required line. Okay. Now, what about next question? Question number 8 here. Find the equation of the plane through this and parallel to this plane. Okay. Eighth question, you want the equation of the plane. So you need a fixed point and the normal to the plane. Remember, you need a fixed point and normal to the plane. In case of line, you required a fixed point and the direction of the line. Now point through which this plane passes is this point is ABC. This is vector A as per our notation, or this is a fixed point. Fine. Required plane is parallel to this plane. Vector r dot, you have here I plus j plus k equals to 2. So what's the normal? This is a normal to the plane. So the same normal will do for required plane. So therefore normal of the required plane equals to the same normal will do, which is I plus j plus k. It's like this. You see here you have one plane, its normal is this. This is the other plane, its normal is this, right? These two planes are parallel, so the normals are also parallel. This plane and this plane, these two planes are parallel, therefore the normals are also parallel. So now you have normal to the required plane, you have fixed point, so you can get the equation of the plane. Therefore equation of the plane, it is r dot, if you recall, vector A equals to here it is vector A dot normal. Actually it is from these only. You can just keep this one in your mind. R minus A dot normal equals to 0. This I have used. So r dot, sorry, here n, r dot n equals to a dot n. I've just opened the bracket here. Now what is r dot n? R is always that xyz. So here normal is this. So you'll get x comma y comma z dot normal. What is that? You know it is 1 1 1 1 1 1. What is a here? A B C. What is normal to the plane? 1 1 1. So therefore you have x plus y plus z equals to a plus b plus c. This is your required plane that passes through the given fixed point and parallel to the given plane. Which concept you have used? Just have a look at diagram. You will realize both the normals are having the same direction. So I've used the same normal for the required plane. Fixed point you are given, and then we have used this vector r minus vector a dot normal equals to 0. I wrote this directly just by opening the bracket. R dot n equals to a dot n, and therefore we'll get this plane. In the ninth question, you are given two lines. There is a fixed point on the first line. This is the direction of the first line. Have a look at the given question. This is the fixed on the second line, and this is the direction of the second line. What is the question here? You want the shortest distance. So let's recall the shortest distance. It is given by this formula. Inside the modulus, difference of two fixed vectors dot here cross product of the two directions b1 cross b2 upon its magnitude. Magnitude of what? Just cross product of these two, b1 cross b2. This is the formula. We had earlier number of such questions. There is one more question in that direction, remember. What is the formula? Let's recall the formula here. Formula is nothing but what? Inside the modulus a2 minus a1, these two vectors, dot cross product of the two directions upon their magnitude. So we just find all these values and we place there. Right? It's not a difficult question. Let me write here vector a2 minus vector a1, that is this minus this. So if we do this, it's a simple subtraction. Minus 4 minus 6 minus 10 I cap minus 2 j cap, this minus this, which is minus 3k. Fine. And now cross product b1 cross b2. You know how to do the cross product. It's a determinant. Here you have I, j, k. What is b1? That is nothing but here 1 minus 2, 2. 1 minus 2, 2. Your 3 minus 2 minus 2. So here this is nothing but what we'll get if we simplify 4 plus 4, which is 8 I cap, minus 2 minus 6, minus 8 and minus sign already there, so plus 8 j cap. Here minus 2 plus 6, so plus 4 k cap. This is the cross product. Now its magnitude, so b1 cross b2 with magnitude equals to here root of 64 plus 64 plus 16. So you will get the root 114, which is nothing but we know 12. Fine. Now we just put the values there. So therefore right here shortest distance, that's equals to inside the modulus dot product of this vector and this vector. Remember here you know dot product minus 10 into 8, which is minus 80. You can write this formula. again here, minus 2 plus 8 minus 16 minus 3 plus 4 minus 12 upon magnitude you already did, which is nothing but how much? 12. So this is minus here 108 upon you have 12. So distance equals to 9 here. This is the shortest distance between two lines. The only thing is calculation point of view you need to see carefully. There should not be any mistake, remember. In the 10th question, find the coordinates of the point where the line through this, so here line passes through these 2 points. Line passes through 516 and 341. Line passes through these 2 points. So therefore, the direction of the line, obviously this minus this. We did it earlier. Direction of the line, which you also referred as direction ratios. This minus this. 3 minus 5, which is minus 2. 4 minus 1, which is 3. And 1 minus 6, which is minus 5. This is the direction of the line. You can take this as a fixed vector A, remember. It's like this here. Line passes through this fixed 2 points, this and the other one this. So this represents the direction of the line here. Vector AB. You can call this as A here. You can call this as B. So this is just vector AB. That's the direction of this line here. Right? So we have therefore the equation of the line. Equation of the line. I'll write in the Cartesian form, vector r equals to vector A plus scalar into direction of the line, which is vector AB. So vector r is equal to, what is vector A? That is nothing but the 5, 1, 6 plus scalar lambda. This is minus 2, 3, minus 5. Where lambda is a scalar, we know very well here. This is the line. Now what is given? You are given that line crosses YZ plane. Right? So as line crosses YZ plane. Now which variable is absent here? X. Therefore x coordinate must be 0 there. X coordinate equals to 0. It's the same as what we were doing in R2. In 2 coordinate axis, if line crosses x-axis, which coordinate is 0? Y coordinate. If line crosses y-axis, which coordinate is 0? X coordinate. So same concept. Here it crosses YZ plane, so therefore x coordinate must be 0. Okay? So you can write x coordinate from this. If I write in terms of components, you can write like this here. You see, I can write 5 minus 2 lambda. Comma, what about this? 1 plus 3 lambda. What about this? 6 minus 5 lambda. Now this must be 0. Therefore 5 minus 2 lambda must be 0. So you have lambda from this. What's lambda? It is 5 by 2. This is the lambda. Now we place this value over here. So we'll get the required point. You are asked the point, remember. So the required point where this line crosses this YZ plane equals to here this will be obviously 0. What about this? 1 plus 3 into here 5 by 2 comma, at this place you have 6 minus 5 into 5 by 2. So this is 0 comma, what about this? 15 plus 2, which is nothing but here 17 by 2. And what about this? Here you have minus 13 by 2. This is the point. I hope You must be clear with the solution. What I did, first I got the equation of the line. This one. This is the required line that passes through these 2 points, remember. I got what? Equation of the line in vector form. Now here you are given 2 fixed points. So first I got the direction of the line. You required fixed point and the direction. How we got the direction? That's vector AB. Then you know this is standard vector form. Now the line crosses YZ plane. Which variable is absent here? X. So X coordinate must be 0. So I got the X coordinate from this, which is 5 minus 2 lambda. It has to be 0. So I got the lambda. So now scalar is fixed, which is how much? 5 by 2. So when lambda is 5 by 2, then this line will cross here, this X, Y and Z here. It will cross which plane here? YZ plane. So this plane here, for example, like this. So here X coordinate must be 0 for this value of lambda. And then in turn placing the value of lambda over here. So you will get the required point where the line crosses which plane? Here YZ plane. 12th question is just copy of it. You are given 2 points through which this line passes. Let one point be A here, which is 5, 1, 6. And the other one is point B here, which is 3, 1, 4. Right? You have these 2 points through which this line passes, A and B. Okay. So first, like the previous question, we get the direction of the line. This is the direction of the line. So I'll write the direction, or you can write direction ratios. Direction of the line, which is given by this vector AB, which is nothing but here, you know, B minus A. 3 minus 5 minus 2, 4 minus 1, which is 3, and 1 minus 6, which is minus 5. 3 minus 5 minus 2, 4 minus 1, 3, and 1 minus 6 minus 5. This is the direction of the line. Fixed point you have. So therefore I'll write the equation of the line. Equation of the line. What's the equation of the line here? Line through these 2 points. Vector R equals to fixed vector plus scalar into direction of the line, where lambda is a scalar. So vector R equals to here fixed vector, that is 5, 1, 6 plus scalar into direction minus 2, 3, minus 5. Like previous question, I'll write in form of components. So you have 5 minus 2 lambda. You have here 1 plus 3 lambda and 6 minus 5 lambda. Right? Now this line crosses ZX plane. Right? It crosses ZX plane, and therefore which component will be 0? Here which variable is absent? Y variable is absent, therefore this must be 0. So 1 plus 3 lambda equals to 0. Right? Again, just remind you, when you consider just x-axis and y-axis, if the line crosses x-axis, you know y coordinate is 0 because y variable is absent here. If line crosses y-axis, then here x component is 0. Same concept. ZX plane. So which variable is absent? Y. So this has to be 0. And therefore lambda equals to minus 1 upon 3. Now you want the point where this line crosses ZX plane. So we just put the value of lambda here. So the point will be here 5 plus 2 by 3, comma, this one has to be 0, 6 plus 5 by 3. Fine. So if you just simplify here, you will get the 17 by 3. This one is 0. And here you will get the 23 by 3. This is the point. It's just copy of the previous question, remember. The 12th question, you are also given here line through these 2 points. So let's take one fixed point as vector A, which is 3 minus 4 minus 5. And the other one, that is point B, I'll call 2 minus 3 1. It's more or less like previous two questions. Now you want the point where this line through this 2 point crosses the plane. Okay, so first we get the equation of the line. So we need direction of this line. Here line passes through these 2 points A and B. So what's the direction of this line? Vector AB. So direction of the line, that is equals to vector AB. So here it will be this minus this, B minus A. You have minus 1, plus 1 and 6. This minus this, this minus this, this minus this. Okay. And therefore the equation of the line in vector form, equation of the line is here vector r equals to fixed point plus scalar lambda into direction of the line. Now just place the value of this and this. Get the values in terms of 3 coordinates. You know, I did twice in earlier questions. Now this line, you get the 3 coordinates in terms of lambda. This line crosses the plane. Which plane? That is 2x plus y plus z equals to 7. Therefore the coordinates of this will satisfy this plane. So you have 2 into first component here plus second component here plus third component over here equals to 7. You'll get equals to 7. Right? Just put the first component in form of lambda here, second component in form of lambda here, third component over here, because it crosses this plane. So therefore components of this line satisfy this equation. So if you simplify, you'll get the lambda from this, and then put the value of lambda in turn over here, so you'll get the point. What you need to do, just simplify, so you'll get the lambda, and then place the value of lambda over here, so you'll get the required point, the point where line crosses the given plane.